Hi everybody, a few technical difficulties there. Hope you can hear me okay now and also see the stream. You might just indicate in Slack if you can. Okay, that's great. So we'll get started then without any delay. So welcome along to week 8. You're getting a break after this week to work on your assignment. There'll be no classes next week, which should give you all a chance to get that assignment in. This week we're going to be progressing on from where we finished last week. Let's just do a little introduction to catch you up. So this is what we were looking at last week. We had switch over to IntelliJ. We did a recap on object-oriented programming, looking at accessors and mutators and toString, our constructor methods. And we looked at a specific class called scanner for doing I/O in Java. We also did I left actually the array recap because literally you could just play back the video in your own time to look back on when we were looking at arrays. And there was a couple of labs for you to do. In the labs we were looking at shop version 1.0, which made use of the scanner class and setting up a class as well. And you also got your second assignment handed out to you. So we moved over to Java proper last week. We replaced the processing IDE with IntelliJ IDE. And I just point out at this stage, your second assignment is still done in processing. But as what we're doing is getting you ready for your third assignment, which will be done completely in IntelliJ. Second half of the course, again, is Java proper done inside of IntelliJ. Okay. We also see that when we make that move over, the setup routine goes and we replace it with main in Java. And from here on in, we're taking an object-oriented approach, all programs now using classes. So we built shop version 1 last week, and we used some graphics to help you out with that. The scanner class was part of Java utilities, and we'll be looking more at that today. And again, more on arrays. Okay, so this week we're going to develop our shop application a bit further from one product to a number of products. So we need to store a collection. The classes we're going to be working with are driver and product. For shop version 2, we have an array of products. So we keep track then of the number of products that are in our shop. So we have the concept of a new class called store. And as we work through the different versions of the shop, just like we did with Pong, we're going to have to refactor our code as we go along. Now, something new in our theory this week is something called an array list, which is a further development from arrays. So it's important that you're comfortable with arrays, and then we get into array lists. And array lists are one type of collection that we're going to be using inside of Java. And we'll be looking at a few others as well. And then we have shop version 3 refactoring version 2 to use an array list instead of an array. Okay, so the buzzword for this week is array list. Okay, that's the main item on the agenda. Taking a look then inside of sorry, just one second. Yeah. So taking a look inside of our website, this is what you should be seeing for this week. We have today's class and then Wednesday's class. And then the content has been split into 2 units. Which we can take a look at. So we're going to be looking at 8A today, and inside of 8A we're looking at shop version 2, and then we're going to introduce this new notion of an array list. So all the slides related to it are here, and then you've got a lab. On Wednesday we'll continue looking at array lists. We'll dive in a bit further, and then you'll also have a second lab to do. Okay, so that's the agenda for the week. So next up we have shop version 2. So I'm working through the slides that we've distributed to you. At this stage, can I just get everybody to give me a thumbs up in Slack, please, so I can see who I'm dealing with. If you've just joined. Oh yeah, you've done it already. That's fine. Okay, I can see who I'm with. Great. So shop version 1. This is what we did last week. We had the notion of a driver class and a product class. And we said the product class is going to store details about a specific product. And the types of information we were storing was the name, the code, the unit cost, and whether it was in the current product line or not. The driver class has the main method. The main method is what gets is the equivalent of our setup in processing. It's the method that gets called first when you run your program, and it has the job of reading in the product details from the user via the console and then creating a new product object. And once that product object is created, finally we print out that product object. So that's what the driver class was doing in version 1. So in version 2 we're going to introduce a new class, and the new class is called store. This new store class is responsible for maintaining a collection of products. So rather than having it in the driver, we're going to have it in the store class. So we're going to create an array of products. Again, if you remember, version 1 just had one product. The reason we need the store is because we can have multiple products, and we're going to store those multiples of products in an array. So driver will now allow the user to decide how many product details they want to store. Because we're using an array, one of the issues with an array is when you initialize the array, you have to specify how big the array is. So if you're going to store 100 products in your store, or have the capacity to store 100, then you have to create the array to have 100 elements in it. You can't resize it later. Okay. So the concept of declaring how many you want to have in your store, how many products you can possibly store, versus how many you actually have on the shelves. Okay, we have to keep track of those numbers. So that's what we're going to see as we look into this class. So version 2 has changes to the classes. We're going to be changing the driver class, make some changes there, and then we have this new store class which is completely new, and we'll be writing all that from scratch. Product then has no changes. So for our store class, we're looking at the interface here that's in IntelliJ. Hopefully you can remember some of this. So I'm going to switch to ask you a few questions. Let's switch to, let's see. Let's switch over here to Socrative. If today's classroom is called Prog Fund, as in Programming Fundamentals. If you'd like to log in there, please, everybody. I'm going to ask you a couple of questions. Okay, so what does the C stand for? So here's our view in IntelliJ. What does this C stand for? Cool. Class is correct. Well done. Okay, let's ask you another one. Okay, there's a little bit of a delay there, so I'll just hang on. Okay, let's. I think that's everybody at this stage. So let's finish that, and we'll ask you another one. Okay, what does the M and F stand for? We'll ask the two of them together. Okay, so M for method and F for field. Great stuff. Okay, that's good. And you're all wide awake. That's great. So we have in this class store, we have 1, 2, 3, 4, 5 methods, and we have 2 fields. Okay, so we're going to look at that in a bit more detail now. So here's our fields. Sorry, I'm just pausing there. I got a pop up. Somebody's having trouble getting into Socrative. Let's see who that was. Okay, Ian, I'll sort that out for you in the next break, if that's okay. I think what it is you've got a leading 0 on your student number. So I guess if you do not put in the 0 and try log in, you'll probably get in fine. Okay. And I'll update that next chance I get. Okay. So we have products and total. These are our fields, and you'll notice that if we look here, total is just an integer, but products is an array, because we have these square brackets. It's an array of product, where product is a particular class. So we have an array of items where each item in the array is an actual object. We also have a constructor for store. Again, thing to notice here is that store is a capital S for store, and we have a method that's starting with that capital S, and it's the same name. And the constructor gets called to initialize our object. Just before class, if you check on Slack, we had quite a good question there from somebody asking about calling the constructor from within inside of the class, and I've given I think a comprehensive answer on that, and the answer is that you shouldn't actually call a constructor inside the class, but maybe there's methods within the constructor that you can call. We also have private methods, and these private methods indicated by the lock suggest that these methods are only available to be called within the class. So we have whether it is full or whether it is empty. And what these methods are doing is they're going to be checking against total. How many? So it'll look at the total field to find out have we reached the maximum or is it 0? Okay. We also have a setter method. This is public, and we use this for adding a product to our store. And then we have a method called list products, which is very similar to the methods we've seen previously called toString. We said it's a good idea to have a toString method in each of your classes, and this allows products to be printed out. Okay, so here's the code, and you can see our fields are private. We have the private keyword here. We have products is the name of the variable or field, and it's an array of product class. Then we have total, which is just an integer. Both of these are private. Now, my question is, why are they private? I'm going to ask you that inside of Socrative. Here. So let's finish that one. And let's go why private. So Ian, I know you had trouble getting in the last time. I'm pretty sure I just have the wrong student number for you. So if you'd like to drop the 0 from your student number, the first 0, and see if you can log in, then you should be okay. I'll fix it later. Okay, I think I've everybody just about, possibly one more. No. Okay, let's take a look. So the first one, you don't want them changed elsewhere later. Almost right. You don't want them changed elsewhere, and elsewhere being in a different class. So that would be a good idea. Okay, next one, to adhere to the rules of encapsulation and to hide the fields from other classes. Great, perfect. So they cannot be accessed by out-of-class methods. Yep, you're all getting the idea. To have access to them within the class only, I think, is what's missing on that one. So they can only be accessed or changed within the class. Yep. So that the value of the field can only be changed by calling the appropriate setter method. Yeah, that's fine. You probably want to extend it a little bit because you can also read it using the getter method. So it's not fully complete. And then for encapsulation reasons. Yeah, okay, so you're all after picking up on that from last week. That's great stuff. Well done, guys. Okay, back to our slides. Where are we? Here. Okay, so now that we've made those fields private, we then have to have methods to be able to get at them. So we have the notion of our constructor here, which is the store, which takes in how many items do you want to store in this class. So we're saying products equals, or assigned a value, a new product with the number of items that's taken in, and then you set the total to be 0. So what we're doing here is initializing our object. We're creating this product store, and we're saying how many products can be in it, and then we're saying how many do we currently have, and that total is 0. And then we have all the other methods that you might want to implement, which we see here. So we have is full is testing if the total equals this. So the total is a test. We're returning total if it's equal to products.length. Now products is, remember, an array, and we saw with arrays that the .length property, as opposed to method, gives us back how big the array is, how many elements are in the array. So if we want to test if it's full, and we've said we want to store 10 products, and we've just initialized our store, then what we're saying is total would currently be 0, but we had created an array which had 10 elements in it. So if you're testing 0 against 10, it's going to be returning false, so therefore is full would return false. Okay. We have another method called is empty, and this is testing if total is 0. So at the moment, when we first initialize our object, which one of these returns true? Is full or is empty? And let's ask you that over here. Sorry, there we go. Which one returns, what did I say, true? Is full or is empty? Okay. when we first initialize. So once again, we've just created a new object and we want to run is empty and is full. Which one do you think is going to return true when you first create this store object? One more. Cool. So which one returns true? We see is empty, is empty, is empty, is empty, is empty, 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 empty. Bar one. So when you first create the store, you don't have any products in it yet, but you've initialized it to accept products. So we would expect to see that is empty is the correct answer, and is full would be incorrect. Okay, so if you mentioned is full there, you got the wrong end of the stick. You might just bear that in mind. Okay, thanks for that. Now back to here. So we've gone through is full, we've gone through is empty, and we're now just going to take a look at adding a product. What happens when you add a product? Okay, so I'll just build up these slides. We have is full and is empty effectively are getters. They return the state of the fields, and they are private member methods. If we look at add, which is what we want to look at next, this is a setter. Add makes use of the private method is full. So what we see here is if is full, then return false. Otherwise, in other words, you're not allowed to add products if you don't have any space to store them in. You can't make the array bigger because the array has a fixed size. So in other words, it's already full up. You can't accept any more products. So we're doing this little test to test, is it full? If it is, just return false. Otherwise, we want to use up the next available space in the array by setting products total to be the product that you just took in. And then we increment total and return true. So I suppose what's new here is we have the add method takes in a product parameter that's of type class product, and we're using the total as an index into our products array in order to store the product that we just took in. Okay, nothing too difficult. We also have this list products method, and this is a toString type method which lists all the products out, making use of the private method is empty. So let's take a look at what's happening here. So list products is the name of the method. It returns a string, takes in no parameters. Checks if it's empty. If it is empty, then the string that gets returned is no products. Otherwise, we do have some products in there, and we need to build up or concatenate a string. So we have string, list of products is assigned a value, an empty string. So this is setting up an empty string, and then we loop through all the elements in the array. So for int I is assigned a value 0, keep going until I is less than the total, adding 1 to I every time. And what you do every time around the loop, we have list of products plus equals I plus a colon with a space, and then what is the value of the current product? So it's products I, and we're putting a new line character on the end. So this is all stuff we've seen before. And then we return at the end the list of products. So after you've visited every element in the array, we're just returning this list of products. Okay. Okay. So next up, what we're going to do is to get you to write a toString method for the store. So I want you to write out what you think the toString method would be for this store. And you can make use of any other method that's already in place. So that might make this a little bit easier for you. I'm going to get you to post your answer again on Socrative. And I'm going to put a timer on this. I'm going to give you about 2 minutes. So we're asking you to write the toString method for our store class, and you can make use of any of the methods we've already seen. Okay, let's see how you're getting on with that. Okay, let's take a look at the answers. Let's see what you've come up with. System run out, print line, list.products.toString. Okay, not quite right. So we're looking for you to write the toString method. So you wouldn't write it by defining it in itself, because you'd end up in a recursive call. Also, the toString method doesn't specify the output. So you're saying system.out.println. If you're doing that, then you're actually trying to write out what the answer would be, as opposed to building up the string. So we're focusing on building up the string. Let's see what the other answers are. ToString list products. Not quite right. Okay. Public string, ToString, return list products. This is closer. Yep. This is closer. We already have a method list products, which will build up a string of all the products. However, there's one piece missing here, and the piece that's missing is, in addition to listing out all of the products, we might also want to know the total number of products. So remember what the ToString method does. It prints out the value of an object, and there's two parts to our object. We have all the products that are stored in the products array, but we also have how many products do we currently have. We're currently storing that value, so we'd want to print that out as part of the ToString. Let's see what else we've got here. So we have public string, ToString, yeah, string, list of products gives assigned a value blank. You're going through them all. So effectively what you're doing here is implementing list of products. But you okay, list of products. Yeah, almost right. Again, I think it's missing the number of products in our object. And this one on top, return products are list of products. Okay, I don't think anybody's quite got the answer correct there. So let's take a look at it. I think you'll all benefit from this one. So this would be a very handy way of implementing ToString for this class. So again, let's just step back and take a look at what we actually had before we broke up there. We had this method called list products, and list products will visit every element in the array called products and build up a string. So you see what's going on here. We have for int I, assign the value 0, keep going while I is less than total, incrementing I every time, and it's building up a string. List of products plus equals I plus colon. So this is saying product 1 colon, and then product 0 colon, and then products 0, whatever the value that's been stored for that, with a new line character. So keep going around the loop, giving the index plus the string that's for the product, describing the product, and it will keep doing that, building up this list of products, and then it returns list of products as the answer, which is a string. So because we have this list products method, it makes it a bit easier then to implement the ToString method, which we see here. So we'll have the ToString. Let's get that up here. ToString is the name of the method we want to write. So we have an opening brace and a closing brace. Now inside it, all we have to do is return a string, and the string is total plus total. So this is the string total because it's inside of double quotes, and added to that string we're adding the number, which is the field total. So that's the field in the class. So what we'll get is something like total colon space 3, which would be, for example, for 3 products. And it puts a new line character straight after that. Again, we've seen these in earlier classes. And then added on to that, we're calling the method, and this is the clever bit. This is what made it easy. This.list products. We already have this method list products, so we can just call it, and it returns a big long string, again, which will be made up of multiple new line characters. So what we get is the total as the first line, and then all of the individual products added one after another to this string, and we'll return that all as one big string. Remember, the ToString doesn't output to the console. Its job is to create a string to represent what is the current state of a particular object. Okay, and that's why we tend to have them in most classes that we define. Okay, is everybody able to follow this this example? Any questions? I think it'd be good for you to ask now. Why do you include this with the list product methods? Good question. So I'm asked, the question is, why are we having a toString given that we always also have the list products method? Well, if you look on screen here, you'll see exactly why. I'm going to draw a line and hopefully that will clarify it. If I draw a line down here, okay, list products would be, for example, it'll say product 0 is shoe, and then product 1 might be jumper, and product 2 is bag, for example. Okay, I have a total of 3 products, so it's going to print out total colon 3, and then underneath it it's going to print out, or sorry, create the string which has all of these strings added to it as well. So why do you need both? List products only does the right hand side of my line, and we need a toString so that it prints out everything. Sorry, I'm blocking the screen there. So the reason you need the toString method is because we want to represent every field that's in the class, including the, in this case, the total field as well as the products field. Okay, does that answer your question? You okay with that? Another one coming in, why use the this modifier rather than just the list products method? Because we are this refers to the object that you're currently working on. That's the easiest way of explaining that. Remember, we could have potentially you could have multiple different objects, and whenever we're referring to an object, we try and be as specific as possible, so that this is whichever one you're currently working on. Okay, all good? Right, let's move on. So we also need to make changes to driver. There's 5 changes to this class to be made. Let's take a look at them. So the first one is the product object is removed and replaced with the store object. So remember, we wrote shop version 1 last week, and we're moving to shop version 2. We have some changes to make. These are the changes. Second thing we do is we have add product. This is changed to add the entered product to the array. We now have an array of products. We also have a new method called process order, and this reads in products from the user. And we have a main method changed to call the process order method that we just spoke about. And then finally, we have print product changed to print out all the products in the array. Okay, so we're now going to go through each one of those to see what code changes take place. So the first change was the product object is removed and replaced with the store object. So that's just a new line there. Then we have the new method process order reads in products from the user. So we prompt the user using system.out.print how many products would you like to have in your store. Then we have a variable number of products, and that takes in the input from the user. We're using input.nextInt to read in that number. Remember input here. Previously, this is an object variable of type scanner class. And the scanner is how we read in input from the console. So small change there. Then when we create the store, the number that we just read in is used to initialize the store object to be that number of products. And that's the important one. I've put a star on it. You want to make a note of that. And then we have a loop which is going to add products to that array. Okay, so we're adding a product. So next then we have main is changed. So instead of just reading in a single product, what we're now doing is we're going to be calling process order. So we have an object C, which is a new driver, and then we use c.processOrder, and then eventually we'll use c.printProduct. So the fourth change was add product. Change to add the entered product to the array. So again, we've seen all of this stuff before. Enter the product name, which was reading in a string, reading in an integer, a double, a character, and then setting the boolean value based on the char value that was typed in. Just highlighted the first line there. This is a dummy read of the string to clear the buffer because there's a bug in the scanner class. So this just makes your program get rid of that problem with the bug. Okay. And then at the end we have store.add new product. Let's just go back there and highlight that. Store.add new product, and then we pass in all the variables that we've just read in. So again, remember what's happening. We're trying to set up our store. We've said how many products we want in the store, and then we read in those products from the user by prompting and then reading reading the input from the user. So what we end up with is product name, product code, unit cost, and the current product all have values in those variables, and they are all then passed into creating a new product, as we see here, 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 and here. So the values that you've read in, you're going to add those to the store by creating a new product, passing these parameters in to the constructor of the product. Okay. So fifth step then is to print out the product. Change to print out all the products in the array. So we have a method called printProduct. It uses systemout.println, and then we're using store.listProducts. Okay. So, summary of the shop: we have a driver class, we have a store class, and we have a product class. We've been making changes to driver this week, and we are moving stuff out of driver into store. So we had 5 changes to make to the driver class, and the store class is completely new. Store class maintains a collection of products, that is an array of products, and the driver allows the user to decide how many product details they want to store, and then the methods are updated to work with this new store.products array. So that's a summary of shop version 2. I've taken a lot longer to go through that than expected, but it needed it, so be it. And I think if you have any questions, you can post those now. Otherwise, I'm going to give you a little breather. Let's put up 7 minutes on the clock, and we'll take a breather. Okay, let's resume. So we're going to take a look now at grouping objects. This is the first of 2 sets of slides, which we'll finish in the next class. It's based on Chapter 4, Objects First with Java, Practical Introduction using BlueJ. Okay. So topic list, we're going to be looking at grouping objects, developing a basic personal notebook project using collections. So this notion of collections, and the first collection we're going to look at is called an array list. So indexing within collections, we're going to be looking at retrieval and removal of objects and how that changes the indices. We're also going to be looking at generic classes and specifically array lists this week, and then we'll look at others in subsequent weeks. And because we've got a collection, we need to be able to visit each element in the collection. We're going to be looking at the for loop and while loop again, which we've seen previously, just as you did with arrays, but we're going to use that for loop and while loop with this new thing called an array list. And we're going to introduce the for each approach to iteration as well. And then in the next class, then we'll move on to coding a shop project that stores an array list of products. So let's get started with grouping objects. So the requirement to group objects. Many applications involve collections of objects like personal organizers, library catalogs, and the student record system. What's common to them is the number of items to be stored varies. Items can be added, items can be deleted, and as a result, you end up with a different number of items. So the issue with an array is that you've got a fixed size array. You then have to have a separate variable to identify how many elements in the array are used up. It's not very efficient. There's a better approach, and the better approach is to use a collection. With the collection, we keep track, this object keeps track of the number of items and also adding and deleting re-indexes, as we'll see in a minute. So here's an example of a personal notebook, the notes application on the iPad, for example. Notes may be stored, individual notes can be viewed, and there's no limit to the number of notes. It generally tells you how many notes are stored. So you don't have to know in advance, I need to be able to store 10 notes. Okay, so it's got a different way of storing. So the Java API is a class library. It has many useful classes and we don't have to write everything from scratch. That's the advantage. Java calls its libraries packages. So a piece of terminology, we have the Java API, we have the notion of a library. Another name for library is a package in Java, and packages contain individual classes. So I have this graphic here, which hopefully it looks very complicated, and yes it is, but just to point out something, if you see here over on the right hand side, Java SE API. So this box here represents everything inside of that area, which is all of this, are referring to the Java SE API, which is what we're using, Standard Edition API. So within here we've got multiple libraries. The libraries are for user interfaces, integration, base libraries, language and util based libraries, and the Java virtual machine. So within each of these libraries, we have individual classes. And you've already used some of these, so you've already used the language and util. So again, the labels on the left hand side are referring to packages or libraries within the Java API. And then we have individual classes, for example, the java.util package. And we use that for our scanner class. So grouping objects is a recurring requirement. The Java util package contains classes for doing this, and the classes that we were referring to are the collections framework. So that's the topic of this talk. So here's a diagram to show you the Java collection framework. So I've highlighted in pink here the collection framework up at the top. You'll notice above it we have the notion of iterating through a collection, and which we see here, and we can come back to that later. But at the top of the pile really is the collection framework, and within that we have 4 types of collections. We have lists, sets, queues, and maps. Now we won't have time to do them all, but we will cover at least 3 in the coming weeks. So lists, sets, and maps are the ones that are coming up. And we're going to start with lists this week, and we see at the bottom these are the actual classes then within Java that we'll be creating. So we have different types of lists. We have an array list, a linked list, a stack, and a vector. So 4 different types of lists in the Java util package. For sets, we have hash sets, linked hash sets, and tree sets. For queues, we have priority queue, an array queue, and a linked list. And for maps, we have a hash map, a hash linked map, a hash table, and a tree map. Again, these are things you will see in the later weeks, or the latter weeks of our program. But for today, we have the concept of we're using the collections framework. Here it is, the collection. And we're looking at lists this week, and a specific example is the array list, and that's what we're looking at in today's class. So we're looking at the array list collection. We specify the type of collection, which is an array list, and then the type of the objects that it will contain. So we're going to start with an example of storing an array list of strings. So this is how we would refer to it, an array list of string. You might make a note of that if you're making some annotations yourselves at the moment. It'd be good to write that down, an array list of string. So in order to use array lists, we have to import that class from the Java util package. So we have import java.util.ArrayList, imports the ArrayList package. We then declare notes as a private array list of string, that phrase I asked you to write down a second ago. Again, looks a little bit strange. We've got a variable called notes. We want to create an array list collection. But what type are you storing inside the array list? Well, we're storing strings. So we have angle brackets around the word string. This is creating an array list of string for our notes variable. And what this allows us to do is to create this collection where we don't have to know in advance how many notes we want to store. It will just create them as needed, delete them as needed, and keep track of how many is in the list. So this is how we then initialize our notebook. Notes is initialized by calling the constructor using new. So we have our notes variable that we declared up here. Now we're going to initialize it by assigning it to be a new array list of string, and we want to call the constructor for that. So we have the open and close brackets. So it doesn't read particularly well unless I highlight the colors. So what I have here is saying note the new keyword and the parentheses. Okay, so this is how we initialize an array list of strings. Okay, so these are the first 3 steps that we'll take to using our collections. Now, just a little aside, you can combine, just like we did with arrays, you can, and strings as well, you can combine the declaration, this second step, with the third step. There are occasions where you might want to do that. Okay, but we won't look at that just for the moment. So let's look at our structure with object structures with array list. What we've got is, in this example, we have a notebook called My Book. Notes points to an array list of strings. Now each element in that array list of string is pointing to specific strings. So this one is pointing to buy bread, and then the second index is pointing to another string, rechargeable phone. So we could add a third note, and the third note here is 11:30, meet John. Notice what's happened. We've got a new element in our array list, and it's pointing down to this string. So the features of an array list collection are: it increases its capacity as necessary, it keeps a private count, and we can get at that using the size method. Again, you'd probably want to make a note of that. It keeps the objects in order. Details of how all this is done are hidden. Does that matter? Does not knowing how prevent us from using it? Well, why don't you answer that? Let's ask you that in Socrative. So let's finish that. Does it matter? So this is the question. Details of how all of this is done are hidden. And what I'm asking you is, does that matter? Does not knowing how prevent us from using it? No, but probably good to find out later. Okay. Yeah, no, it doesn't matter. So it doesn't matter that we don't have to implement it. The whole point of using object-oriented programming is somebody solves a problem and they give you access to that solution. So you can just use the solution. You don't have to worry about implementing and reinventing the wheel over and over and over again. So that's the reason why we use all these libraries, because the libraries have solved the problems that you're about to embark on. So if you can use those solutions and just know how to call them and get back the answers, then that's better than having to start from scratch. So you're going to be able to develop code faster, and that's the nature of how we develop software. Okay, thanks for your input on that. Let's move it on. So here we have some code to create our notebook. So I've highlighted in red how we would add a note. So we have our variable from before, our notes variable, and we're saying notes.add the current note, the note that was passed in. So this is how we add a new note of type string, and this is how we return the number of notes. Remember we mentioned on the previous slide the size method is how we said an array list of strings keeps track of how many notes or how many elements are in that array list, and we can get at that using this size method. So when we're implementing our notebook, we can just return notes.size. Okay. So next we move on to indexing within collections, retrieval and removal of objects. So what we're going to be looking at here is the indices. We looked at indexes when we were looking at arrays, and when we use collections, there's an additional problem that we need to take a look at. Now, luckily, when we use an array list, it manages all of this for us, but it's good to see how it actually, or what it's actually doing. Okay, so we have, again, previous example, we have 3 notes stored in an array list of strings. Notice the indexes are 0, 1, and 2. So the index for the first buy bread is index 0, recharge phone is 1, and 1130 meet John is index number 2. So if we retrieve an object, we might want to use something like show note. If we implement show note, then here's what we'd have to look at. If the note number is less than 0, in other words, the note number that you're asking us to display, if you're saying that's less than 0, then it can't be a valid note. So that's some error handling or validation. Else, if note number is less than the number of notes, then we're in the range where it's 0, 1 or 2. Otherwise you have a problem. So the first if statement and the default else are validity checks. We've mentioned these before. But the bit that does the work is the bit in the middle here, where we want to use or show or display the note that's stored in this array list. So we've got system.out.println, and then the important bit, notes.get the note number. So remember what's happening here. We've got a method. This method is called show note. It's trying to display one of those strings that we saw on the previous screen. You need to know the index into the array in order to be able to display the correct note. We've got a validation to check if it's a negative number, then it's not a valid note. If it's greater than the number of notes that are in the array list, then it's again not a valid note number. Otherwise, we're ready now to display the note. And we've seen system.out.println before. Remember with Java, system.out prints out to the console. The println is the method that you used in processing for printing. So we just tie all of that together. And then inside of the brackets, we have the new bit. So it's notes is the name of our object, which is an array list of strings, .get, and then we specify the note number. So that's the get method is going to return a string, and then we're including that in a println statement to output to the console. Okay, likewise for removing an object. If the number is less than 0, it's not valid, so you don't do anything. If it's greater than the number of notes that we're storing, again, it's not a valid note number, so you don't do anything. Otherwise, you do want to remove the note. So we have notes.remove. So remove is a method for removing an object from an array list. So after you do your removal, you'll notice that we're now only got 2 items. I removed the middle one, but you'll notice that the index numbers have been updated. So that's what's been managed by your array list. So the string had an index of 2 before removal, this 1130 meet John. That did have an index of 2 before removal. After you remove it, notice that the index gets updated to be 1, so that we get a continuous set of numbers. So let's look at that side by side. On the left hand side, we have the before picture. Again, we have buy bread, recharge phone, 1130 meet John. The size of that is we have 3 notes, so that's the size. Notice the indices 0, 1 and 2. When we invoke a removal by calling the remove method, and we're going to remove the middle one, so I'm going to rub that out. What we'll see is the after picture. We still have buy bread, we still have 1130 meet John, but what's important to make a note of is that the indexes have been updated. So although we deleted index 1, we still now have a 1. So what was 2 becomes 1. That sounds like a line from a song, but there you go. So again, note the change in the index numbering. So now we get on to generic parameterized classes, our array list. This is from the documentation online in Oracle. We've looked at this in an earlier class. And what you notice here was that we've got class array list, and then you've got angle brackets and an E, and the E is a parameter for a specific type. So collections are known as parameterized or generic types. Note the E is the parameter, and E gets replaced with some class or type. Here's an alternative. We had strings previously. This is how the documentation looks for the class string. It's just class and string. And then side by side, the array list has this extra part to it, which is the parameterized type. So the type parameter, in this case angle brackets E, says what we want a list of, and that can be a list of anything. We're using an array list of string, but that could be an array list of person, an array list of ticket machine. It could be an array list of integers if you wanted. It could be an array list of anything. So an array list implements list functionality. These are the methods that you can call on it. It has an add method, which appends the specified element to the end of the list. We have a clear, which removes all the elements from the list. Get returns the element at the specified position in the list. So if you said get 1, it'll return the element at position 1. Remove 1 will remove the item at 1. And then size returns the number of elements in the list. So what I've done here is copied directly from the website for the Java documentation on array lists, and I just cut out what you need to know. And this is a summary of it. So we have an array list, and we have some methods that we need to be aware of. We have add to add an element to the array list, clear for clearing it, get gets you an element within the array list, size tells you how big it is, and remove for removing it. Okay. So there are methods, and then the last bit then is how do we visit each of the elements in an array list? So we're going to have to use iteration. So processing a whole collection or iteration, we often want to perform some actions an arbitrary number of times. For example, print all the notes in a notebook. Most programming languages include loop statements to make this possible. Loops enable us to control how many times we repeat certain actions. So we've already seen the while loop, we've seen the for loop, and we've talked about the do while loop. Some of you have used it already, others haven't. The difference between a while and a do while is with a while statement, the condition appears at the top. With a do while statement, the condition appears at the bottom. The while statement may never enter the loop. A do while will always enter the loop at least once. And we've all used the for loops. So loops are not new to us. You typically use a for and a while loop to iterate over your array list collection. Or there's a new one that we're introducing, and that's for each. You can use another special construct associated with collections, and it's called the for each iterator. So we'll come to that in a minute, but let's look at the for and the while first. Here's the for loop pseudocode. Again, this is old ground. We're just recapping how for statements work. You have an initialization section, you have a test, and then every time you go around the loop, you're doing something to the loop control variable. So here's an example. The initialization for int I is assigned a value 0, I less than 4 is the Boolean condition, and then the post body action is incrementing I, and then we perform statements inside the curly braces every time we go around the loop. So this is the initialization, the Boolean condition, and the post body action. And then the flow chart. So I'm just going to fly over this because we've done all of that before. But here's a for loop now with our collection. So we're iterating over a collection. So what's different? Well, we still have our for statement, but for each value of I less than the size of the collection, print the next note and then increment I. Let's take a look at how that's implemented. We're using the size method to tell us how many positions in the array list we need to visit. So that's all that's different. And then when we want to visit an element in the array list, we use the get method. Okay, so again, I would encourage you to strongly make a note of this slide. This is going to help you use array lists. So that was the for loop version. Let's look at how we do that with a while loop. Very similar. Again, I'm going to skip over this quickly because we've already done while loops before. It's all old hat, flowchart. This is the important slide. And what we see here is we have a while statement. While I is less than, and just like we did with the for loop, we have notes.size. Every time we go around the loop, we're going to get the value at I. I is the loop counter variable that we're incrementing every time we go around the loop. Okay, so again, we're using size and get in order to visit each element in the collection. In our case, we're using an array list. Okay. So for versus while, if you want to look at the two of those side by side, the variable I is a loop control variable. Then the test is notes.size, and the post body action is incrementing the loop counter variable in this example. Okay, so a couple of minutes left and we're on to the final thing today, which is the for each loop. So the for each loop pseudocode, it's a for, and then this is new. So this for element type, element colon collection, loop body. So the way we read this is for each element in the collection, do the things in the loop body. So we have the for keyword, our loop header, the statements to be repeated, and then we go back around the loop. So now we're seeing some new syntax. So we haven't seen anything like this before. This is how we list all the notes using the for each loop. For each note of type string in the notes collection. So what I'm reading here is the bit inside the brackets here. So we have a for statement, and actually that should say for each. So it should be for each and then string note colon notes. And the way you read that is for each note of type string in the notes collection, print out the note. So here we have print line note. Okay, that's the bit to make a note of. So it can only be used for access. You can't remove retrieved elements, and you can only loop forward in single steps. You cannot use to compare two collections. For each versus while, for each is easier to write, it's safer, it's guaranteed to stop. With the while statement, we don't have to process the whole collection. It doesn't even have to be used with a collection, but take care of getting into an infinite loop. So for each, again, easier to write and safer, guaranteed to stop. Our array list collection then, the type of collection is notes. The type of objects it will contain are going to be strings. So we say notes is an array list of string. So let's summarize everything we've done today, just about on time. We are talking about the Java collections framework, and we're looking at a specific element within here called the array list. In order to use the array list, we have to have an import statement from java.util, and we'll specify array list so that we only import that one. Here we're creating notes, which is an array list of strings, and the private keyword makes it private to the class. Notes is a new array list of string. Here we're calling the constructor method to initialize the notes object. This is how we add a note. This is how we get the size, how many notes do we have, how many items are in an array list. This is how we get a specific one. This is how we remove one. And then the last bit we looked at was iterating collections. We saw this new example of a for loop for each, which is highlighted there. So apologies for the lack of interaction in the last half hour, but it was important that we just make our way through this summary. And I would say that's the takeaway slide from today's class. That's got all the key elements that you need to make note of. So if you have any questions on today's class, you can post those to Slack. Otherwise, we're going to be continuing with our array lists in the next class, the next day. Got some more work to do. What we'll be doing is taking the theory that we've introduced today and applying it to the shop example that we're working through, and we'll create a new iteration of that shop application to make use of array lists. Okay, so thanks very much. I'm going to stop there because we're out of time. Okay, thanks very much. Again, questions in Slack if you do have any. Okay, bye.